Thank you, Alistair, for the introduction. So just to lead in from Paul's discussion as well, I'm going to focus a bit on sort of the workflow and the full life cycle of a project once it comes to us or once it comes to me. I get involved essentially once an order is placed, and I'll manage the project through the remainder of the design with the architects and engineers, and then into our shop drawing process through fabrication, and then on site with site assistants. And so I'm going to go through firstly, I'll touch on the manufacturing process so you can see how we actually make the CLT, and then I'll go back to before that. When we do our shop drawing, I'll just explain our shop drawing process and what we need, what sort of information we need to start that, and then I'll look at some site images and explain how we build these structures. So just an introduction to XLAM. Paul touched on this, so I'll just run through it quickly. But started in New Zealand. Mayflower company, which is owned by the Hine family, purchased the company in 2015. You'll know Hine from Hine Timber, which is where we get all of our feedstock timber from. It comes out of the Tumbarumba region, about 2 hours northeast of our factory, which is located in Barnawartha North, which is near Wodonga. We opened the plant in March 2018, so been under 12 months ago. Since that time, we've delivered 40 projects ranging from large commercial buildings through to boutique houses and testing projects for universities and whatnot. Like Paul mentioned, so XLAM sort of doesn't want to be seen as just a material supplier. We do a lot more than that. So we want to sort of provide solutions to the market. So at the moment, we've got a range of different options. XLAM design or fee for service is something that our head of design, Nick Houston's really heading, and that's doing the upfront engineering design of the CLT structure. Product development, so we work closely with developers on developing concepts, say modular construction. So we'll get in and help under non-disclosures if we need to, and develop concepts out of CLT. Value add is something we've been doing for a while in the factory. At the moment, we do things like pre-slinging our panels for lifting on site. We clad our panels in vapor membranes. We're now starting to do insulation products, battening. We're even now starting to look at pre-fitting windows and door frames and things like that. So like the video Pal I showed before with a fully finished panel coming to site, we're trying to get down to that sort of pathway now. And the on-site assistance as well, something that I'm involved in. So getting on site through the build and acting as sort of a lead foreman or assisting the lead foreman to build the structures. So we can certainly get involved with that front as well. So understanding the fabrication process, I think this is quite important. It's one of the key. The manufacturing process is really the main process that I think you guys need to understand how we make the panels and what's the most efficient way to design them and fabricate them. So a quick run through of the fabrication. It starts at the back end there. We have the raw feedstock timber comes in. It gets finger jointed together. So every board's end to end finger jointed. It then gets docked into a long length of timber and stored in some curing decks up here, curing the glue in the finger joint for 7 minutes, and then it goes into the planer, which is that little white box there. Out the end of the planer, we have long lengths of timber, and then they get split up and then go into another docking saw that cuts it into the short boards. The press lay up here, so you've got long lengths there and then short lengths that are transferred across to the other side of the press. Vacuum cranes come along and lay up the panels, so we start with long boards or short boards, whichever wall layup or floor layup you're doing. Glue's applied automatically between each layer, and then the whole billet is put into is rolled into the press here. It's pressed for 25 minutes, and then it comes out, takes a left, and goes around to the CNC. The CNC here, Hundiger PVA machine. It's a brute of a machine, so it's designed to pump out structural panels. It's got very large tooling and equipment in it. It's got about 5 or 6 different motors inside it, so each powering chainsaws, saws, disc mills, slab cutters, router bits, pen marking tools. It's got quite a lot of tools in there. It is designed to process very large panels. It's a very heavy machine that runs on a set of rails either side. It spans about 5 metres across. The panel slides inside it, and then the machine itself runs back and forth as it processes the panel. So it can do intricate little details on panels, but just keep in mind it is a very heavy machine that's moving on these rails. It's not sort of designed to do finite details and write your names in panels and that sort of stuff. So we can do it, but it does come at a cost. So what we like to tell people is just because the CNC can cut it, it doesn't mean you have to. So some things like this fancy little seat here, or putting shapes in panels, just keep in mind that those things do obviously take time. A summary of the factory, or the considerations of factory: 30-minute billing press cycles, so 25 minutes to press it, but 5 minutes to change over. We do 2.4 by 6 is the smallest billet we press, all the way up to 3.4 by nearly 16 metres. The CNC, if the CNC takes more than half an hour to process a panel, it becomes the bottleneck. So we have to stop the front end line. We can't keep producing the billets because the CNC is going to hold up the line. So the goal for us is to process billets within that half an hour period. What we ask, or the question that we ask ourselves is, do we sell timber or do we sell production time? It's really a function of both of those things. So we sell a base timber element, but then we have additional costs for extra CNC time. There's two functions of what alters the cost in CLT, so panel size and panel complexity. I'll give you an example. If you've got, say, a 20 square metre billet, it might take 15 minutes to process. If you've got two 10 square metre billet panels that go into that billet, it won't necessarily take 15 minutes to process anymore. It might take half an hour, or it might take 20 minutes. So smaller panels take a longer period of time. There's more handling in it, so more crane movements off the CNC. And then complexity is the other thing. I'll get to that in a sec. Complexity, like routing GPOs or doing slots or hidden lines or shadow lines on panels and that sort of stuff, will obviously slow the process down again. So Paul touched on this example as well. I'll just explain each of the options. So obviously, top one is a large format panel with windows cut out of it. The bottom one is a framed wall lintel scenario. The top option is a lot quicker for us to process. There is waste involved in that. It is a bad thing to obviously consider the waste, but we do recycle all of our waste in untreated, so it's from our point of view, it is a better option to go with the top one. It's cheaper. We charge a less of a panel cost per square metre for large format panels. You will probably end up paying more for that in the factory and on site, because you've got more lifts, more fixings, more connections and whatnot. So have a look at that early on, and again, get us involved if you want to sort of discuss these things and look at where you can get your efficiencies. This is an example of a billet, so a nested billet. One large format billet with one panel on it versus the same size billet with multiple panels on it. You can see 23 minutes to process versus 140 minutes. And that's the actual times that we've taken from our software. So almost 6 times the amount to process that there. So obviously it will come at an additional cost. Connections as well is something that's really important. It really drives the complexity of the panels. So an example there is a hidden T-plate connection with a slotted T. It's got detailed shadow line there and a rebate for a bolt on the other side. So both of these connections are performing the same function. They're an internally exposed wall with the connection made on the external face. This scenario here, we've got to do a shadow line route. We've got to route this chamfer, the slot at the bottom for the chamfer. We've got to slot the panel for the T and pre-drill the holes for the bolts. This scenario here, we'd have to do absolutely nothing. It's a simple equal angle with a packer in between. We've also got a 20mm tolerance between the CLT and the floor, whereas it's not built into this system here. And allowing your tolerances to alternate materials on site is something that you really need to consider. So generally 20mm tolerance to all concrete, 10 to steelwork, and timber to timber elements, we normally allow sort of 2 to 3mm tolerances, so in our joints and that sort of stuff. So looking at the design for manufacturing assembly, I'm going to run through just a typical project that we're working on at the moment. It's a house down in Ceres near Geelong. So level AK are the architects, VizTech are the engineers. And I just want to explain sort of how we get to the shop drawing stage, or how we get to a level where we can start our shop drawing process. So it starts with the architect, as it always does. So they'll develop their 3D models and initial 2D drawings. It moves on to a structural engineer, this is VizTech in this case, who will do a finite element analysis model and detail all the connections. This is 2 pages of about 9 that are developed for this project. So obviously a lot of detail that goes into these things. Paul mentioned as well on his slide with the traditional versus the offsite, where you've got a larger portion in design but a shorter portion on site. So obviously quite key to make sure you've got enough time allowed for in the design to get these details right. It goes back to the architect then to finalise the architectural drawings, so updating all their drawings to make sure all the right panels thicknesses are in there, so that we've got all the data we need to start shop drawings. When it comes to us, we take the structural drawings, the details, we take the architectural set-out plans, and we start to develop our models. It's often the case where we'll have to start from scratch with our models. Architects are normally sort of not quite at the level of detail that we can just simply grab the model and put it straight into our software for our machines to cut. So we need to tweak the models and make our own. We then develop individual QA drawings, what we call them, which is an individual shop drawing of a panel. It's during the shop drawing stage where we work quite closely with the builders to develop sequences, so understanding your site constraints and what crane you're going to use, what the capacity of the crane is, where you want to start and finish your build. We build all that into our sequence for the shop drawings. So we develop truck loading diagrams, so every panel comes to site in a pack. You unload the truck onto the ground, and then you open the first pack and you've got number 1 panel on top, and you just start picking from the top of the pack. So coordinating all that very early is very important to make sure that you're getting the efficiency on site with the construction. Again, if you don't allow enough time, that shortened construction period sort of won't be achieved. So you need to make sure design time is allowed for. The devil is in the detail is something that a lot of people are saying now. I think it's really the money is in the detail, and it's the time that's in the detail. So just again, I want to reiterate, make sure you allow enough time to get that detail right. The summary, allow enough time. The consultants are also quite important in that process. Obviously, they've got a heavy involvement in the design, so make sure that you're employing the right designers, the right architects and engineers. It's quite often where we'll have clients come to us saying, I've got a domestic house and I want to use CLT. It's all fully designed in frame at the moment, but I really love the product and I want to use it. And then we get through the process, and then it turns out the architect's finished up with their work on the job, and the builder doesn't want to get them back involved, and then the whole design needs to be driven by us, and we don't really know where we get our geometry from, and it gets quite convoluted and hard. So make sure that your consultants are willing and able to assist with that sort of upfront process. Design large format panels, rectangular shapes where possible, simplify connections, understand your site and develop sequences for transport and erection. Coordinating foreign trades is a big part of that as well. So there's no reason why you can't order your windows and doors off plans now, because if you're dealing with prefabricated materials, they're generally fabricated to 2 mil tolerances. So if you've got a 600 by 900 window, we'll make a 610 by 910 opening, order the windows well before so that they're arriving on site a day or 2 after the CLT goes up, and you can close your building in a lot quicker and make sure that you're protecting it. And importantly, consider the structure built when we start our shop drawing process. So as we get through that design with the architects and engineers, design is frozen, it's considered built at that stage. We start shop drawings from then on. I'll look at some construction images now. So I like to show this picture because I think it has a lot of similarities to a prefab CLT installation. In this picture here, we've got 21 workers. Each of those workers know exactly what they need to do. They know where they need to be and when they need to be there. It's a very streamlined process. If you've seen it, you'll obviously know this, but in about 2 to 3 seconds, this car can pull in. It'll be lifted off the ground. All 4 tyres will be changed. A bit of fuel will go in. They'll clean the front spoiler. They'll wipe the driver's visor. Car will get dropped down or drive off. So 2 to 3 seconds for all that. Obviously, this is on another level, and it's obviously at the extreme. But CLT job sites are run no different. Every person on the job site needs to know what they're doing and what their role is to play in the installation. So we refer to hook-to-hook time as our sort of, the car driving in and then driving off. So hook-to-hook time means from the time in which a panel is hooked up, installed, and then the crane's returned back to the point in which the next panel's hooked up. It's important to try and move as many processes out of that hook-to-hook time as you can. So looking at, can you attach props to the panels as they're sitting on the pack rather than when it's hanging in the air? Which side of the prop attaches to? Is there any connections that I can pre-install or pre-drill? Is the lifting points been installed? All that sort of stuff. So look at what you can get those guys to do to really make that hook-to-hook time efficient. We generally run our job sites with 4 to 5 people plus a rigger and a crane operator. Within that, you've got about 2 people installing the panels themselves, actually landing the panels and getting the set-out points right, unhooking the panel, putting the fixings on, sorting the prop out. One person generally follows with installing all the permanent fixings, so they're chasing the install team. And then another person will be located at the pack of timber in the laydown area, making sure the next panel's ready to go. So, that person's quite key in the whole process because they've got, all the loading plans in front of them, making sure that, the next panel's the one at the top of the pack or it's not sitting over there and where it is. And then the 5th person is generally a non-working or a partially working foreman who'll sort of be conducting the site and making sure everyone's working to their as efficient as they can. We implore people to really understand the model and the detail. So our modelling, our 3D model that's fully detailed is what's sent exactly to the CNC machine. So every panel that's shown in that model is exactly within our tolerances, of course, but exactly what's sent to site. So if I get a phone call and someone's saying, oh, this beam's too short, and I can see it in the model that it's not too short, I know that they've probably built the columns in the wrong spot or something like that. So it's never failed us up to this point. So, but yeah, having the foreman really sort of understanding the model, having the software and a laptop on site so that they can look at the detail, take measurements where they need, and get panel information is quite critical in the process too. Couple of images now. Making the structure weather tight is very important. Taping joints of floors is quite important. It's the main area where water can get through into the lower levels. So the panels themselves are quite watertight in that they won't allow the water to pass through the panel. It will still sort of absorb into the panel because it is timber. So just keep in mind taping the joints. If you are going to experience a downpour of water, just make sure you're sweeping all the water off the panels, all that sort of stuff. Structural connections, make sure you understand the connections and what fixings you need. Make sure you've got them on site and they're handy and you're not running out. Lifting methodologies, we have a few different techniques. Pre-slinging, which I'll go through in a second, is our standard lifting technique, but there's other options for situations where you might have visual panels where you don't want to have a sling going through the face. We can pre-install ferrules into the panels in the factory, and you can wind in lifting eye bolts and lift from them. There's another system is a clutch system. Different people make different clutches. Rotorblasts have one that's just a simple screw into the panel, and the clutch hooks onto the screw. But different systems which provide the same, it performs the same way as the lifting ferrule, where you can use it on visual wall panels and not impede the face of the panel. This is our sling. It's a soft sling, 1 ton soft sling that's threaded through a 40 diameter hole in the panel, so about 300 from the top edge in wall panels, or at 4 points on floor panels. Floor panels, the sling is slung through the panel and back up through the other side. So this is by far the most robust and safe lifting option on site, because you are sort of slinging through a hole and it's grabbing the hole. It's not sort of relying on a lifting or a fixing point. every panel that we supply out of the factory is pre-slung with these slings unless you're adopting other lifting methodologies. And when you're finished with the lifting, you simply plug the hole with a supplied timber plug. We send these out, so it's a visual wall panel. Just with your selection of plugs you got on site, match the grain and hammer it in. It's you know, when you get it right, it's fairly unnoticeable. These are some good examples of how to get it right on site. So this is a job up in Canberra we worked on. Pre-fitted plywood onto the floor penetration, so they're not a tripping hazard on site. All the joints are taped. They've pre-installed balustrades on panels prior to lifting. All the columns there are prefixed to their positions in their design, and they're just leant over. So when that next panel comes in, the prop's just laid over and screwed in, and they're done. So that's another process that you can take off that critical path with a hook-to-hook time. All the connections are set out, ready to be installed. Some of them, which you probably can't see that well, but are already actually fixed into the ground on their set-out points. So you're just bringing the panel in, dropping it on the ground, fixing it off to the bracket, putting the prop on, and moving on to the next panel. Even things like pre-installing screws halfway. This is something that the guy sitting at the pack can do. If he's got the design in front of him, he knows it's 300mm centered screws on the ground. He can start pre-installing the screws for them. This is awaiting for the panel behind to be installed, and then they'll just simply finish off the screws with those two guys that are installing. And coordinating services is another big part of it as well, just to gain efficiencies there. So we do a lot of that in our factory. I know it's contradictory to the complexity that we say to try and simplify, but when we look at the cost of doing things like this, it generally outweighs the cost of what it would take you to do it on site. So just looking at what's beneficial for that sort of stuff. This here is a door. The client on this job, and we're starting to do this a bit more often now, but the client wanted to use CLT as a dining table for the project, so they wanted some off-cut material. So we've left the door in here and made the pilot cuts, so they'll simply finish it off on site, pull the door out, and they'll get to use the material. This is a large format panel, so they're already paying for that wastage because of the way we press it, so there's no reason why that can't be done as well. Bathroom pods are a good addition to mass timber construction, obviously, because it can drop into the rooms as you're building it. Pre-installing balustrades, I mentioned earlier. This is something that we're doing quite often now, is part of our value add system, is pre-fitting steel connection plates and that where they're required. So this job was the steel plates were supplied by the client, but we can procure them as well if you want us to do that and pre-fit them in the factory. Some of the things to watch out for. These are custom lifting points that the client on this chose to use, but they're mild steel and they will rust. So when you get rain, you'll start to get staining occurring. That's very hard to sand out. So just keep in mind on something like that, you'd at the very least galvanise it or prime it. Put a plywood packer between that and the wall. Cut an angle on the bottom so it acts as a drip groove and you don't get any water sort of running down the face of the panel. UV staining is something as well that we need to watch out for. It will happen on any projects, no matter what you try and do, because it is sitting out in the sun when you install it for a period of time. But looking at protection fabrics or some materials to temporarily clad the face if they're visual. The staining, the UV staining does stand out fairly easily. So just keep that in mind. Water mitigation on site is also a very key part of it, as I mentioned earlier, but this is the end grain of a panel will tend to suck water up into it quite easily, so it's a key area there to watch out for. So obviously some water's gotten into this bottom connection, you will not sand that out, it's a permanent staining, so it's very deep into the panel. So if this was a visual panel, which it's not in this case, you'd have issues. I'm happy to say that none of this is our CLT. This is, however. So this is obviously what can happen when you get a lot of rain happening on the panels. This should be swept off immediately. You do get blackening occurring on floor panels on site, so don't worry about that too much. We always recommend against exposing CLT floors because it is just pine, it's a softwood, so and because it's something that's going in on site on day one, it's very hard to sort of mitigate damages and that with the floor. So you wouldn't ever dream of putting a nice hardwood floor on day one and then drive plant on it and have people drag ladders on it and stuff like that. So just keep that in mind. it will sand down prior to finishes going on. So if you're doing any carpeting or direct sticking carpet on there, you do need to give a thorough cross sand to get the levels back to flat. So the timber will tend to crack a little bit, and gaps will open. You'll get some cupping. None of that is really a structural concern for us. It's just more of an aesthetic thing. So just keep that in mind as well. And lastly, this is something I saw on site last week, but this panel here was unwrapped and it was left out in the weather for a period of time that I don't know, but I can only assume that it's got rained on, it's dried out, so it's gone through some temperature extremes, and you can see here what happens. You've got pretty severe gapping opening here, cracks in the panels, a bit of delamination there, so just keep in mind that protection on site is really integral to getting the project complete in the way that you want to. So we also have a site guide that we've got to distribute as well. So that'll come to you when you sign up with us. It's a 50-odd page document which has got all this information in it. So make sure that that's read through and you're factoring these things into your build. So that's all from me. Thank you.